Welcome everyone. I'm Eric Leblond. I'm one of the founder of Stamus Networks. I'm working in cybersecurity since around 2000, and I've been mostly been on the development side, trying to fix the problem that we have. And I've always been on the defense, so trying to protect network. So never really on the red team. And in my previous life, I was working on Linux firewalling. Now I am more involved in everything that is about threat detection. Yeah, so if I'm here is to talk to you about the new hammer that we have. And I'm going to start with something really obvious. AI is everywhere. You have basically pretend AI everywhere. It's mainstream. Generative AI is in fact what we are talking about. The ChatGPT, the Llama, and all these large language model have proven to give some great results in the life of people. So we are currently reaching the stage where it's like a hammer, and when all you have is a hammer, everything is looking like a nail. So we're currently in this stage. So we try to apply AI everywhere, even when it's completely stupid. So yes, so if generative AI is working over AI, has AI in it, it should work. So we are currently seeing a lot of AI washing because a lot of vendors claim they do AI when they are not doing AI. And that's one of my favorite talks from one of the biggest vendors. I was there at an event 1 or 2 years ago. And so it's a product that is supposed to learn your network and then discover the threat in the network. And then they said, AI is wonderful because before even the model has the time to learn your network, it detects interesting stuff just as clear text password. Okay, clear text password. It's you are looking into the content of the traffic, looking for some pattern, like password equal, pass equal in some correct place in the network, and that's the detection. So it's just nothing but AI. It's good old pattern matching. And they sell it to you as AI. So, yeah. On the same talk, that's in fact my favorite. The guy did, it was the vendor and the customer talking together at the show, and the vendor say, I'm really happy I took this option, because with this option, the day after Log4Shell, so if you remember Log4j exploitation, where it was all over the place, going everywhere in the network, the next day, the model has been updated to detect Log4Shell. The next day, update the model. If you need to update the model to get the detection working, it means that anomaly detection is just not working. So basically that AI is not applied for this detection. So don't get fooled by the AI washing. AI can be super useful, but not everything can be AI, and not everything should be AI. So the black box is really, really interesting for the vendor. First thing, you don't need to show anything about your internal. So basically for intellectual property, that's just perfect. And for the customer, if you say that everything is AI, you don't show the algorithm, it cannot understand in some cases that it's not AI. So that's a plus for you. Everything you are doing is AI. Yeah, on AI, it's magic, so you don't need to explain it. That's also convenient. And in a lot of cases, they hide also behind the excuse of complexity. Dear customer, you are not clever enough, it's AI. You cannot understand because it's advanced mathematics and stuff like that. So if we want to talk about advanced mathematics, Stéphane Mallat was one of my teachers when I was learning mathematics at the university in France. He's now in the chair of data science at Collège de France, and he got in this introductory story lesson at Collège de France. In this lecture, give this sentence that for me was kind of a breakthrough. So the solution in most data science problem can be seen as finding a median hyperplane in a space of really high dimension. Okay, so that was your 2 minutes of mathematics, but let's look at what it means exactly. You have, in a lot of machine learning algorithm, something that you can easily visualize in 3D. You've got different points with different labels, and it's kind of a cloud, and you try to find a plane to go between the blue label and the red label that will be the solution of your problem. In a lot of cases, it's like that. A lot of problems, you can solve them like that. But the thing that we have here is that it's high dimension. You can visualize the plane, but you cannot visualize an hyperplane. Above 4 dimensions, the human mind is just like, you cannot get it. You cannot see the logic. You cannot grasp what is happening. You cannot visualize the data. You cannot even try to, what you can do with such a problem is to grab a few values, check if it is correct, but you cannot even, you got too many values, you got so many dimensions, you cannot even understand what it is about. So inherently, you got some really efficient algorithms that are black box. You cannot apprehend the result. You cannot apprehend what has been done because the complexity, the number of dimensions is too high. And we're talking about sometimes billions of dimensions for some model. It's really too high for you to understand what is happening. So, yeah, you can, it's black box. So let's talk a little bit about security. So we have the large language model. Yes, it generates content, super useful for red teaming. You can generate content and then attack people with something that looks really plausible. So you can also use it for the blue side, basically doing, for instance, you got threat intel, you compute the threat intel, and you got some nicely formatted data that you can understand and then inject. And yeah, so you need verification for sure. The results have been generated automatically, so potentially you need to verify them. But it's really useful to take on or make decisions based on it. So now come another point. If we are talking, for instance, about detection or decision making in the context of AI. So if you have a detection on a database that is critical, should you shut down the database? First, there is one thing. You need to know that the database is critical. And the second thing is, does the AI algorithm know that the database is critical? It's not because there is a switch on, switch off button that you should use the switch on, switch off button if it's really critical for your infrastructure. Potentially, there is some more useful and practical way to do this, and you need to know the impact of a decision. It's really the key to know what you are going to do. If your AI model has no information about the criticality of what you are doing, it's going to propose you some wrong result because it does not know about it. So you need to be able to ingest that into your AI algorithm or to have manual verification in this case. It's really the security decision is a balance between the risk and the cost. So everything depends on that. And yes, that was the easiest slide to do in this presentation. I just connect to ChatGPT, get the prompt, and I read the bottom line. ChatGPT can make mistakes, check important info. So if you are about using AI to take a decision, you just need to remember that it can make mistakes. It is not a human being that knows everything about your environment. It has basic data that it is working on. It takes prediction based on this data, and that's all. It is missing a lot of context, a lot of side information that can help you to take good decision. And the algorithm can also just screw up and give you some bad result. So you need to take that into account. So now we know that it's going to fail. So what should we do? First, just ask yourself, I have data, and I need to analyze this data to be able to take a decision. Is the human analysis of the data taking longer from checking the result of the AI algorithm? The AI algorithm is going to give you some potentially unexplainable result that you will need to dig into. So is it going to cost you more to just look at the data yourself instead of using AI to analyze the data? And trusting AI, it's a bit like what I've said before, depends on the impact of bad decision. If you move a mail to spam box, that's recoverable. People are used to getting things in the spam box because they know since years that spam box can have wrong decision. So that's not really a problem. We can recover the mistake. But if we are talking about the database example from before, if I need to shut down the database, that's something else. So you really need to trust AI. Trusting AI depends on the impact of bad decision. So yeah, moving something to spam, yes, let's trust AI. If it has 1% failure rate or even 10% failure rate and it's helping people, that's not really a problem. And if you need verification because the action can be harmful, in this case, you just need to ask yourself what is the cost. Because if you need to validate things and it takes time, you will have a human cost associated to it. And the cost effectiveness, we are going to dig into that a little bit later with a simple example. It can be not what you thought, because when you are looking at the classification of algorithm, in a lot of cases, what people are just considering is the rate of false positive or false negative, wrong detection, good detection on the system, and are not taking into account something that in a lot of cases is really important. And this thing is the context. So IOC is definitely not AI. It's a good old technique of indication of compromise, so an IP that is known to be bad, a domain that is known to be bad. But it applies so much to the result of AI that we should just take this into account. So yeah, so it was somebody from a European CERT that was saying at a conference, if an IOC has no context, we don't use it. Because if you just know it's bad, what should you do with that? It's bad because what? What is the impact? What is the reason? What should I do with this information that just tell me it's bad? And if you look at AI, because you don't know the result, basically it's just exactly the same as a bad IOC. You have just a verdict on something that you don't really know what to do with, because if you have no context around it, no explanation, you are going to be just exactly like a bad IOC where somebody did not tell you that this IOC is linked to this APT29, APT35 actor. Then you have this information, you know, okay, I'm dealing with that, so I know what I can do. So it's a bit the same with AI. If you have a result and you don't know how to put the context in front of it, then in this case, you are in trouble. You don't really know where you are going. So the context is really critical. You must be able to analyze the decision, and you must be able to analyze the decision without understanding the reason of the decision. Because as we have seen before, in a lot of cases, the algorithm is complex, working on data, and you cannot get the reason why the decision has been done. So the only thing that you can have is to get the most context you can from the system to be able to answer to the question you need to. Is it really an attack? Is it a false positive? Is it a false negative? Is the remediation correct that is proposed by AI, if we're talking, for example, about the autonomous SOC? And yeah, so if you don't have this information, if you don't have this context, you just cannot really use what has been produced by AI. So the next question is, what should we ask then? First, I would say transparency in what has been used. If it's pattern matching, the vendor should just call it pattern matching. No need to hide it as AI. let's stop the marketing people. Sorry if there is some in the room, but let's stop them for a while. Let's try to be honest in what we propose, because we are here fighting to defend network. So it's a complex task. So we don't need to be not helped by our vendor. And yes, on why it's also interesting, because potentially you say yes, but it's just a little lie, it's just hiding things. But yes, but if they say it's AI, they cannot explain you what the match has been on. But if they say, for instance, we take the example of a clear text password, and they assume it's really pattern matching in this case, what you will have is just say, yeah, we look for the password string in this part of the protocol. So for you, it's trivial to analyze behind. It is going to take you 2 seconds to understand that, oh yes, password was not in the correct place. I can understand what is happening. But if they say it's AI, it's magic. You don't know what has been found inside. So yeah, you are in trouble. So if you are transparent on the detection method, then in this case, you can have something that is easy to understand, and you can go further. And another thing is that sometimes you can have different algorithms that are going to give you answer to the same problem. So you can have a black box algorithm that is really complex, that is going to give you some result that can be really accurate potentially. And that's nice. But you can also have a white box or clear box algorithm where you understand what is happening, what data have been used, what kind of a logic has been applied. You can go back into the explanation of a decision. And this type of algorithm offer you some transparency that can be really beneficial. And in some case, a bad clear box algorithm may be better from a good black box one. So let's look at one simple example. So let's say that you have on your environment 100 problems that you need to find to be able to react. So let's take a really good black box algorithm. It is going to just have 2 extra false positives on top of a 100 element. So it's going to detect 100 events plus 2 that are false positive. Let's take a clear box algorithm that detects 150 events and 50 false positive, 100 true detection. And yeah, the things that this algorithm detect, the event, we need to act upon it. Like it's the critical database case, which means that we need human validation. So if we need human validation, we need to do a careful analysis of what has been found to be able to say, okay, yes, no, need to apply, I can apply the remediation, I cannot apply, I should not. So if you take something that with a black box algorithm, the complexity of the analysis will be stronger, so you need, for instance, 30 seconds to do the analysis. You have 102 elements, so basically you have a bit more for 3000 seconds. If it just takes you 10 seconds in the other algorithm to analyze the 150 events, basically you just won half of the time. Yes, the clear box algorithm sucks. It's bad. The performance is indubtably worse from the other one. But in terms of impact, you are going to spend less time working on the clear box algorithm result to be able to trigger your response. So which one should you pick? The black box because, yes, super high precision? No. Clear box is going to be better for you in terms of usage. So, if you have now, in some cases, you're not going to have the opportunity to use a clear or white box algorithm. In this case, you need to use some black box algorithm that are going to give you some result that you need to analyze. And here, the only thing that can help you to get a better understanding is the transparency, because It can help you to understand what are the data input, on which data it is working. So, for instance, if you know that you are working on that on this type of data, and then you know that in your environment these data are really strange, or somebody suddenly put something in production that was not there before, then you can understand why you have an anomaly. If you know on which data it has worked, if you don't know, you're lost. And also you can, knowing the type of data that is used, it can be helpful to get the context. So, yeah, providing context is helpful. For instance, let's take this simple sentence. We got a beacon detection algorithm that is based on flow volumetry and frequency. That's simple. You know what type of data it is using. You don't really know the internal. It can be completely hidden to you. But you know at least that these data have been used. And so you know that what type of entries are used, so you can potentially check them to get back to your fit and understand what is happening. And also, what you can do is also take other information, like, for instance, if one of the beacon is over TLS, you can then extract the server name indication or all the parameters like the certificate. So you got the more context, and if the beacon is on Microsoft.com, potentially you don't really care, or if it's on some their domain, then it's useful, and then the detection makes sense. So yeah, so getting context outside because you know what has been used is really useful. So yeah, so almost to conclude, as Stamus Network, that's something we really believe in, transparency, because yeah, if you are clear with what you are proposing, it is going to help you to understand and act fast on what has been detected. Yep. And yes, so it's one part of our solution, Clear NDR, that is a network detection and response solution where we want to provide a clear detection because if we are transparent on the detection, then you can act on it and get the best you can of your network data with regard to threat detection. So yes, one last thing on Clear NDR is that we have a community edition and an enterprise edition. So if you want to try it, you can use the community edition, or you can contact us for the enterprise edition to do a POC or stuff like that. And if you want to do some further reading, I recommend you the Gartner report and the 2 articles from IBM and from Mr. Vanderburg on Explainable AI. Thank you.